Book 2, chapters 3 to 6 of 10 books on architecture. This LibriVox recording is in the public domain. Recording by Fredrik Karlsson. 10 books on architecture by Vitruvius. Translated by Morris Hickey Morgan. Chapter 3. Brick. 1. Beginning with bricks, I shall state of what kind of clay they ought to be made. They should not be made of sandy or pebbly clay, or of fine gravel, because when made of these kinds they are in the first place heavy, and secondly, when washed by the rain as they stand in walls, they go to pieces and break up, and the straw in them does not hold together on account of the roughness of the material. They should rather be made of white and chalky, or of red clay, or even a coarse-grained gravelly clay. These materials are smooth and therefore durable. They are not heavy to work with, and are readily laid. 2. Bricks should be made in spring or autumn, so that they may dry uniformly. Those made in summer are defective because the fierce heat of the sun bakes their surface and makes the brick seem dry while inside it is not dry, and so the shrinking which follows as they dry causes cracks in the parts which were dried before, and these cracks make the bricks weak. Bricks will be most serviceable if made 2 years before using, for they cannot dry thoroughly in less time. When fresh undried bricks are used in a wall, the stucco covering stiffens and hardens into a permanent mass, but the bricks settle and cannot keep the same height as the stucco. The motion caused by their shrinking prevents them from adhering to it, and they are separated from their union with it. Hence the stucco, no longer joined to the core of the wall, cannot stand by itself because it is so thin. It breaks off, and the walls themselves may perhaps be ruined by their settling. This is so true that at Attica, in constructing walls, they use brick only if it is dry and made 5 years previously, and approved as such by the authority of a magistrate. 3. There are 3 kinds of bricks. First, the kind called in Greek Lydian, being that which our people use, 1.5 feet long and 1 foot wide. The other 2 kinds are used by the Greeks in their buildings. Of these, one is called pentadoron, the other tetradoron. Doron is the Greek for palm, for in Greek doron means the giving of gifts, and the gift is always presented in the palm of the hand. A brick 5 palms square is called pentadoron, one 4 palms square tetradoron. Public buildings are constructed of pentadora, private of tetradora. 4. With these bricks there are also half bricks. When these are used in a wall, a course of bricks is laid on one face and a course of half bricks on the other, and they are bedded to the line on each face. The walls are bonded by alternate courses of the 2 different kinds, and as the bricks are always laid so as to break joints, this lends strength and a not unattractive appearance to both sides of such walls. In the states of Maxilua and Calais in further Spain, as well as in Pitane in Asia Minor, there are bricks which, when finished and dried, will float on being thrown in water. The reason why they can float seems to be that the clay of which they are made is like pumice stone. So it is light, and also it does not, after being hardened by exposure to the air, take up or absorb liquid. So these bricks, being of this light and porous quality, and admitting no moisture into their texture, must by laws of nature float in water like pumice, no matter what their weight may be. They have therefore great advantages, for they are not heavy to use in building, and, once made, they are not spoiled by bad weather. Chapter 4. Sand. 1. In walls of masonry, the first question must be with regard to the sand, in order that it may be fit to mix into mortar and have no dirt in it. The kinds of pit sand are these: black, grey, red, and carbuncular. Of these the best will be found to be that which crackles when rubbed in the hand, while that which has much dirt in it will not be sharp enough. Again, throw some sand upon a white garment and then shake it out. If the garment is not soiled and no dirt adheres to it, the sand is suitable. 2. But if there are no sandpits from which it can be dug, then we must sift it out from riverbeds or from gravel or even from the sea beach. This kind, however, has these defects when used in masonry. It dries slowly. The wall cannot be built without interruption, but from time to time there must be pauses in the work, and such a wall cannot carry vaultings. Furthermore, when sea sand is used in walls, and these are coated with stucco, a salty efflorescence is given out which spoils the surface. 3. But pit sand used in masonry dries quickly. The stucco coating is permanent and the walls can support vaultings. I am speaking of sand fresh from the sand pits, for if it lies unused too long after being taken out, it is disintegrated by exposure to sun, moon, or hoar frost, and becomes earthy. So when mixed in masonry, it has no binding power on the rubble, which consequently settles, and down comes the load which the walls can no longer support. Fresh pit sand, however, in spite of all its excellence in concrete structures, is not equally useful in stucco, the richness of which, when the lime and straw are mixed with such sand, will cause it to crack as it dries on account of the great strength of the mixture. But river sand, though useless in signinum on account of its thinness, becomes perfectly solid in stucco when thoroughly worked by means of polishing instruments. Chapter 5. Lime. 1. Sand and its sources have been thus treated. Next, with regard to lime, we must be careful that it is burned from a stone which, whether soft or hard, is in any case white. Lime made of close-grained stone of the harder sort will be good in structural parts, lime of porous stone in stucco. After slaking it, mix your mortar, if using pit sand, in the proportions of 3 parts of sand to 1 of lime. If using river or sea sand, mix 2 parts of sand with 1 of lime. These will be the right proportions for the composition of the mixture. Further, in using river or sea sand, the addition of a 3rd part composed of burnt brick, pounded up and sifted, will make your mortar of a better composition to use. 2. The reason why lime makes a solid structure on being combined with water and sand seems to be this: that rocks, like all other bodies, are composed of the 4 elements. Those which contain a larger proportion of air are soft, of water are tough from the moisture, of earth hard, and of fire more brittle. Therefore, if limestone without being burned is merely pounded up small and then mixed with sand and so put into the work, the mass does not solidify nor can it hold together. But if the stone is first thrown into the kiln, it loses its former property of solidity by exposure to the great heat of the fire, and so with its strength burnt out and exhausted, it is left with its pores open and empty. Hence, the moisture and air in the body of the stone being burned out and set free, and only a residuum of heat being left lying in it, if the stone is then immersed in water, the moisture, before the water can feel the influence of the fire, makes its way into the open pores. Then the stone begins to get hot, and finally, after it cools off, the heat is rejected from the body of the lime. 3. Consequently, limestone when taken out of the kiln cannot be as heavy as when it is thrown in, but on being weighed through its bulk remains the same as before. It is found to have lost about 1/3 of its weight owing to the boiling out of the water. Therefore, its pores being thus opened and its texture rendered loose, it readily mixes with sand, and hence the 2 materials cohere as they dry, unite with the rubble, and make a solid structure. Chapter 6. Pozzolana. 1. There is also a kind of powder which from natural causes produces astonishing results. It is found in the neighborhood of Baiae and in the country belonging to the towns round about Mount Vesuvius. This substance, when mixed with lime and rubble, not only lends strength to the buildings of other kinds, but even when piers of it